So let's do something slightly more complicated. We're going to mix two solutions, and this will not have a 1-to-1 mole ratio, so you'll get to see how that works. So this will be 20 milliliters of 0.010 molar silver nitrate mixed with 2 liters of 0.002 molar potassium chromate. We're given the KSP of our our chromate, and we want to know if a precipitate will form by mixing these two solutions. So the first thing you need to do is recognize that if you're not entirely sure what's going to form, when you're given the KSP of something, that's a really big hint. So we're given the Ag2CrO4, we're given its KSP. So now let's look what's actually happening in our solution. We are going to dissociate this into solution, and we're going to dissociate this into solution, and our overall reaction will be this. So this is the piece that we're interested in, but to get here, we need to know what our overall concentration of our chromate is and our overall concentration of our silver is. And then we're going to use the concept of Q to get there. So for starters, and I hate using this equation, we are going to use it because this is indeed a dilution. I have one solution, and I'm going to add it to a second solution, so I'm going to end up with different molarities. So I have 20 milliliters of my silver nitrate, and I'm going to add 200 milliliters, or 2,000 milliliters. Let's just do it in terms of milliliters now. Let's change this, just make life easier. We'll call this 2,000 milliliters. And over here then, I'm going to have the two mixed together. I'm going to have 2,020 milliliters. And I want to know my end molarity of my silver nitrate, AgNO3. Actually, let's write this prettier. I want my end concentration of AgNO3. And the same here. This is going to give us our 2,020 milliliters. And I want to know what my end concentration of my potassium chromate is. Oops, prettier. Okay, so then this whole thing divided by 2020, and this whole thing divided by 2020. So I put that in my calculator, and I get that the concentration for my silver nitrate is this 9.9 times 10 to the negative 5. My potassium chromate is this 1.98 times 10 to the negative 3. So let's see what that looks like. So I come over here and I say, okay, so my concentration here is this 1.98. I'm not worried about this. I am worried about my chromate, but that's a 1-to-1 ratio. So my concentration here is 1.98 times 10 to the negative 4. And I also want my silver. And again, it's a 1.1-to-1 ratio. Let's not worry about our nitrate. And so its concentration is 9.9 times 10 to the negative 5. What we can do now is do our Q. And say Q then will equal our concentrations. But we haven't done something. We'll go ahead and write them in. 9.9 times 10 to the negative, oops, I want more room. More room. 9.9 times 10 to the negative 5, and 1.98 times 10 to the negative 4. Now the trap here is if you find these two concentrations and you think you're done, but let's think about what our KSP is. So for Ag2CrO4, our expression at equilibrium is 2 times this times our silver. So Ag plus CrO4 2 minus. So my KSP equation then is my Ag plus squared times my CrO4. Let's make that look more like it's supposed to. CrO4 2 minus, and that's just by itself. So this quantity is squared, so I must have a square here. So when I put that into my calculator, I get that Q equals, hold on, 1.94 times 10 to the negative 11. So my KSP value was 1.1 times 10 to the negative 12. 1 times 10 to the negative 12 is my KSP. So what does this tell you? This number here is smaller than this. So we are indeed going to get a precipitate out. So another way to think of this is in terms of what we have, right? I could use my KSP and solve for my max concentrations, and I get that 2x, which would be my silver, is 1.3 times 10 to the negative 4. So max concentration for my silver is lower than it needs to be, so we're fine there. But I come over here and I see my x for my potassium is 6.5 times 10 to the negative 5. Oops, this is larger than that. So there's actually two ways that you can look at it. If you want to jump right into your Q, you can. Just make sure that you don't forget this step here. Hugely important, that's squared. Or you can get to your concentrations and compare those to what our maximum amount of soluble product is for each of our ionic concentrations. And we come over here and we look and we find out that, yeah, the one, our chromate, was indeed higher, and so that's problematic. So we would get then a precipitate.